Welcome students, welcome to the class of mathematics. So today we will see how to solve the question of a height and distance. Here we have taken one question where the angle of elevation of a cloud from a point h meter above a lake is alpha, right? Let us assume here the lake is CD, right? This is the lake, right? Lake. And the point is A, which is at height h meter above the lake. So from the height from C, the height of A is h. Let us see. If CA is h, then BD will be also be equal to h, because this is parallel, right? Now, the angle of elevation from this point A, the point A, from the angle of elevation, the cloud. This is the cloud. Let us say this is at P. Now the angle of elevation is alpha. There it's alpha, right? Now we will do one thing. Write it with different color. Let's say it's alpha, right? And the angle of depression of its reflection in the lake be beta. So you can see the angle of reflection, this will not form at O, right? Because PD is the lake and at O, PD equal to DO, right? So DO will also be equal to H, right? So the image will not be formed at O. So here the image will not be formed. Image will be formed at Q, this point, right? Why? Because you can see the cloud is at h plus this height. Let us say PB is the height which is equal to x, right? This is equal to x. Then D to O will be equal to h and O to Q will be equal to yet yes, the reflection of that is x. You know, if this is a mirror, if CD is a mirror, because this will act as a mirror, right? Mirror. We learned in physics the distance of the object from the mirror in front of it will be equal to the distance of the image which is behind the, which is virtual, which is behind the surface of the mirror inside it, right? So this distance, you can see this distance, this one, D to Q, what is it? The length of this will be equal to h plus x, h plus x equal to h plus x. So I will write it as plus x. So the second point which we have left here is the angle of depression of its reflection in the lake be beta. So the point A is the point of observation, right? So the angle of depression the of the image of that cloud, so it will be Q. So the angle of depression will be formed as here as beta, right? Now we use the right angle triangle ABP here. ABP. So let us also assume one more thing, that let us assume AB equal to CD is the width of lake equal to Y. So let us assume yes Y. So AB is also equal to Y. Now let us solve this question. In triangle ABP, right? Triangle ABP, this one, this triangle. What will triangle ABP, right angle at B, right? Tan of alpha equal to perpendicular by hypotenuse, that is EB by AB, right? Now what is the length of PB? We have assumed it as x, right? And AB as y. So from this we can write y as x by tan alpha, right? This is one of the equation we have arrived, right? y equal to x by tan alpha, right? Now just rename it as equation number 1. Now let us go to the second triangle, which is triangle ABQ. This one, ABQ, the bigger one. That is, we will use the reflection of the cloud, which is at Q. That's why we considered ABQ, right? So triangle ABQ, triangle AB, right angle at B, tan of beta, because that is the angle of depression which is given. Tan of beta is equal to PQ by AB, and we know that PQ is BD plus DO plus OQ by AB. What is the length of AB? We have assumed it as y. Of the value into the next step, right? So what is the value of BD? It's H equal to H. Value of DO? DO is again H, fraction of that H, plus OQ. OQ is X, right? Divided by AB. What is the length of AB? We have assumed it as Y. Now, from this, we came to an value that tan of beta, tan of beta equal to 2 times H plus X by Y. From here, we bring the value of y, just pushing y from the denominator of the RHS to the LHS, then tan beta will come from numerator of the LHS to the denominator of RHS. So y equal to 2 times h plus x by tan beta, right? This is our second equation, right? We'll do one thing, use this equation as second, mark this as equation number 2, and number. Do one thing, just equate the values of width of the lake, that is y, from equation number 1 and equation number 2. What we will write? See, from equation number 1 and 2, y is equal to x by tan alpha. You can see here, this one, x equal to tan alpha. This will be equal to times h plus x by tan beta, right? Now calculate the value of x from here. Why we need that? Because if you know the value of x, we know the value of p to b, and we are already knowing the value of y, right? That is x by tan alpha. So from this, we use in triangle ABP sine. Why sine? Because the distance from the point of observation, that is A to P, is AP, that is hypotenuse. This one is H, right? Hypotenuse. We need to find this length. Length need calculated. This is equal to this can be found by either sin, that is PB by AP, or sin of alpha, or cos of alpha, that is AB by AP. But we should know the value of the other variables, right? So let us solve it. So from this you can get the value of x. What is the value of x? Let us solve it. X tan beta will be multiplied with x. That means x in tan beta equal to times h plus x tan alpha. Now bring x times tan beta equal to h tan alpha plus x times tan alpha. Bring x to the one side here from RHS to LHS. Get the value of x, putting x common, get x times tan beta minus tan alpha, right, equal to times h tan alpha. From here we get the value of x as h tan alpha by tan beta minus tan alpha. So here we are able to calculate the value of x. So the value of x is calculated here as times h tan alpha by tan beta minus tan alpha. So just name this as equation number 3, right? Equation number 3. Now we know the value of PB. So if you use the sin alpha, we get the value of PB by AP, and from here we will calculate the length of AP, right? So sin of alpha will be equal to PB by AP, right? Sin of alpha equal to by AB, sorry, AP, and AP is the distance of cloud from point of observation, that is A. You can see here AP, one is AP, right? A is the point of observation, this one. The point of observation, right? So AP is calculated as, from here get the value of AP. Here we get AP as P by sin alpha, and we know what is the length of PB. Length of PB is x. You can see here, right? So that is equal to x by sin alpha, right? That is equal to x by sin alpha. And what is the value of x? Put from 3. From question number 3, AP equal to x by sin alpha, x h tan alpha divided by tan beta minus tan alpha divided by sin alpha. That means 1 by sin alpha. And here, no, tan alpha can be written as 2h sin alpha by cos alpha divided by tan of beta minus tan of alpha 1 by sin alpha. Here what we will do? Cancel out the sign. Here this sign will be cancelled out. Now we are left with times h and 1 by cos alpha. 1 by cos alpha is sec alpha, right? 2h sec alpha divided by tan of beta minus tan of alpha. So the length of AP, right? The length of AP is the distance of the cloud from the point of observation. This one. Distance of distance of cloud distance of cloud from point of observation, that is A. So AP is equal to 2h sec alpha by tan beta minus tan alpha. So what we need, we have s sec alpha by tan beta minus tan alpha. So here you can see we have put this one alpha tan beta minus tan alpha. So in this way calculated the distance of AP. So we can write here as AP as A of P h sec alpha by tan of beta tan of alpha, right? So how to solve these questions and such questions of height and distance we have seen. We come up with more questions, get the fundamental concept too of geometry, how to solve such questions, and always like and subscribe to my channel. Happy learning.